right, folks, right, number 5, about 2 Coast Guard patrol boats leaving Cape May. Okay. One has a bearing of 4230, okay, so we know we've got one there. And the other one has traveling at a bearing of 52 degrees and 12 minutes. So we know that that second boat out here. If they travel at the same speed, how far apart will they be when they are 25 miles from Cape May? Okay. So assuming we're traveling out this way, the other boat's traveling out this way, and they go 25 miles out, they essentially want to know, here's boat number 1 and boat number 2. They want to know how far apart they are. Okay? And if you look at the way they're traveling here, if you look at the way these 2 lines are lining up, we're looking for this curved distance. We're looking for S. So I'm going to work with the formula, arc length equals angle in radian times my radius. Now if I look at those 2 lines, I notice that the angle I need is this one right here. So in order to find that, what I'm going to do is take the 52 degrees, the 12 minutes, oops, sorry about that, and then we also have the 42 degrees, 30 minutes, and we need to find the difference between those 2. Now you can do a few things. You can convert them to decimal and then subtract. Okay, you could rearrange them, put them in proper format, and then subtract. It's up to you which way you want to handle it, because eventually we need it to be in radian anyway, so we're going to have to go through a few steps. I'm going to have the calculator do the work for me. So I'm going to take the 52 degrees and the 12 minutes. And we're going to go ahead and convert that into a decimal. We're going to do the same thing with the 42 degrees and the 30 minutes. I'm going to subtract the difference between the 2, 52.2 minus that 42.5. So right there I've got 9.7. That is in degrees at the moment. No, I need it not to be in degrees. I need it to be in radian in order to use that arc length formula. So I have one more conversion. I'm going to take that 9.7 times pi over 180, because that's my conversion factor to get out of degrees and into radians. And that's going to give me an angle of about 0.17 if we round that off. So that is what I'm going to use over here for my theta. Now the radius, if you read the problem carefully, they did tell you that radius. These boats are going to travel 25 miles each. Okay, so we're going to use that as the radius length. And then I'm all set up to go ahead and find the length of that arc, or in other words, how far apart are these 2 boats. Okay, so you can, if you want to carry over the whole decimal, you certainly can. If you use the rounded out version of the 0.17, that's fine as well. I've got about 4.25. If you carry the whole decimal, of course, that's going to be slightly different. Remember your labels, this is going to be in miles.